Superposition is this mathematical idea that you can break down a linear system into kind of smaller constituent parts, and then the total response is just a sum of all of these individual responses. So expressed in the language of circuit theory, it means that if we have a linear circuit, and that linear circuit contains multiple independent sources, then what we can do is study the response due to each of those independent sources in isolation. And then the total response, or the response to the real circuit that has all of these different sources in it, is obtained by just summing up the responses due to each of those sources in turn. So that might be a fair bit of jargon, so let's explain it with an example. So I've got here a simple circuit, and it has two independent sources, which is a voltage source and a current source. And suppose that I would like to know what is the current I1, which is flowing over here. So how can I actually analyze this? So, I mean, I could, of course, use all of the tools that we've been studying for weeks now, but if I want to study this using superposition, then here's what I would do. So by superposition, we can split this into two, let's call them like sub-circuits, which are the response due to the voltage source and then the response due to the current source. So the response due to the voltage source is. So I'm going to redraw the circuit, and I'm going to turn off all of the other independent sources. So I'll redraw my circuit down here, and then turn off my current source. So if you turn off a current source, it means no current can flow. No current flows when there's an open circuit. So this here now is the kind of sub-circuit that refers to the response due to the voltage source. And what I'm going to do with my label here for I1, I'm going to call it I1 prime. Put a little dash there, because this is not the total I1 response. This is just a partial response. So I can now analyze this circuit. And this one is fairly straightforward, right? I basically can simplify this network of resistors. So in particular, this little branch here, this would simplify, so this portion would simplify to an equivalent resistance, which is 3 ohms in parallel with 2 plus 4. So this is 3 ohms in parallel with 6 ohms. And so that is the product, 3 times 6 divided by the sum, 3 plus 6, so that is 18 divided by 9, which is 2 ohms. So I can kind of redraw the simplified version of my circuit, which has then the 120 volt source with a 6 ohm in series with 2 ohms, and the current that I'm trying to find here is this I1 prime, and here I can pretty much write it down straight away. So I1 prime is going to be 120 divided by 6 plus 2, so it's 120 divided by 8, which, just grab my calculator, 120 divide 8 is 15. So 15 amps. So that's the response due to the voltage source, but I also need to know what is the response due to the current source. So for that purpose, I'm going to redraw my circuit again and evaluate just the response due to the current source. So the response due to the current source is, so I turn off the voltage source. So to turn off a voltage source, I set it to 0 volts. 0 volts means short circuit. So that's the response due to my current source, and I'm going to label it here as I double prime. So that's the kind of second partial contribution to my current here, I1. So again, I can kind of simplify this internal portion of my circuit. So like this bit here, I can try to clean. Actually, no. The way I'm going to do this, I'm going to do a source transformation, starting from kind of this part and working backwards. So source transformation here will give me this. So by source transformation, I have that. Let's just redraw our circuit very quickly. We have 6 ohms, 3 ohms, 2 ohms, and the 4 ohm is going to become connected in series, and we're going to have a voltage source. The polarity has to match the one from earlier. So the voltage on this, so the voltage on the source is going to be, by Ohm's law, the Ohm's law combination of this current. So 12 times 4 is 48 volts. So that one is just 48 volts. Then we can clean it up a little bit further. So I will have these two resistors here are in series. So this will give me 6 ohms, 3 ohms, and these add together to give me 6 through a source. Let's put the polarity the right way around, and that is just 48 volts. Like so. This one's pretty simple. I'm just going to write down the current equation, write down KCL and solve from there. So this one was I1 double prime, the current here that I'm trying to solve. So I'll just write a single, or label a single node here. Let's call it V1, and a reference node over here. And let's calculate our equation. So KCL at node V1 will be this. So currents leaving V1 through the left branch will be just V1 divided by 6. Currents leaving through the bottom branch will be V1 divided by 3. And then currents leaving through the right branch will be V1 minus 48. So be careful with the polarity here. We basically have that the point here to the right of this resistor is 48 volts below ground. So we need a minus there when we do our expression for KCL. So this is our equation for V1. Multiply everything by 6 is going to give me V1 plus 2V1 plus V1 plus 48 is equal to 0. So I have 4V1 is equal to negative 48. V1 is 48 divided 4 is 12, so negative 12 volts. So therefore, our current I1 double prime, if we look at the way that our voltages are labeled here, so I have a kind of a V1 is the positive on the other end of the arrow. This one's a little bit tricky, so let me draw it more clearly so that you can be clear about the polarity of what I'm talking about here. So I have, from my circuit diagram, there's my circuit diagram, I have a V1 that's defined that way, and I have a current, I1 double prime, which is defined that way. So the current flows from negative to positive. It's the opposite way around to how conventional current flows. So my Ohm's law for this situation is negative IR, because the current flows the other way around. So putting some labels on here, this is V1 is negative I1 double prime times R. So we can substitute in what we know. So V1 is negative 12. We have negative I1 double prime, and our resistance is 6 ohms. So therefore, cancelling the negatives on both sides and bringing the 6 to the other side, I have I1 double prime is 12 over 6 is 2 amps. So we can, therefore, by superposition, the original current that we were trying to find is the sum of the individual responses. So that's the response due to the voltage source, is the first term, and then the response due to the current source is the second term. So those numbers were 15 amps and 2 amps. So 15 plus 2 is 17 amps. So the summary of how to use this method was that we turn off the other sources and we solve for the response due to each of the individual independent sources, and then we can just add them up. It's a linear circuit, so it's a kind of a linear combination of all of the individual sources of energy, and that was how we were able to analyze this circuit.